So in today's video, we're going to try solving this question. And it says, when the square root of x multiplied by the fifth root of x minus the fifth root of x multiplied by the square root of x is equals to 56, then you have to solve for x. To solve this question, we are going to use quite a number of rules of indices. Now, the first rule we are going to use is the fractional indices rule. And it says when you have a raised to the power of 1 all over n, it can be written as the nth root of a. So when you have something like 4 raised to the power of 1 all over 2, it can also be written as the square root of 4. Another rule we're going to use is the multiplication rule. That says when you have a raised to the power of m multiplied by a raised to the power of n, it can be equals to a raised to the power of m plus n. Now, another rule we have is the power of a power rule. So we have, when we have a raised to the power of m or raised to the power of n, it is equals to a raised to the power of m multiplied by n. Now try remembering these rules because we are going to use them in solving our question. So we have our question. Now the first step we're going to use the first rule, which is the fractional indices. So we're going to use it on the fifth root of x here and the square root of x here. So when we apply those rules, we'll have our equation rewritten as the square root of x multiplied by x raised to the power of 1 over 5 minus the fifth root of x multiplied by x raised to the power of 1 all over 2 is equals to, since x here is equals to x raised to the power of 1, we are going to use the multiplication rule, which is when you have a raised to the power of n multiplied by a raised to the power of n, it is equals to a raised to the power of m plus n. So when we apply that rule, we have the square root of x raised to the power of 1 plus 1 all over 5 minus the fifth root of x raised to the power of 1 plus 1 all over 2. Now when we add these fractions, which is 1 plus 1 all over 5, we will have 6 all over 5. And when we add 1 plus 1 all over 2, we have 3 all over 2. So this will give us the square root of x raised to the power of 6 all over 5 minus the fifth root of x raised to the power of 3 all over 2 is equals to 56. Now again, we are going to use our fractional indices rule. So when we have a raised to the power of 1 all over n is equals to the nth root of a. So we are going to apply it on this side of our equation. So when we apply that, we have x raised to the power of 1 all over 2 multiplied by 6 all over 5 minus x raised to the power of 3 all over 2 multiplied by 1 all over 5 is equals to 56. Now this 1 all over 2 here is representing our square roots, and then the 1 all over 5 is representing our fifth root. So when we multiply, we have 6 all over 10 and 3 all over 10. So we have our x raised to the power of 6 all over 10 minus 3 all over 10 is equals to 56. When you look at our left hand side, we have x raised to the power of 6 all over 10. Still using the laws of indices, you can say our x raised to the power of 6 all over 10 is equals to x raised to the power of 3 all over 10 all raised to the power of 2. So when we bring that back into our equation, we have x raised to the power of 3 all over 10 all raised to the power of 2 minus x raised to the power of 3 over 10 is equals to 56. Now the next step we're taking in solving this question is to substitute. So we can say let p be equals to x raised to the power of 3 all over 10. Now when we substitute that into our equation, we have that our x raised to the power of 3 all over 10 all raised to the power of 2 can be written as p square, and our x raised to the power of 3 all over 10 is p, and then we have our 56. So our equation is p square minus p is equals to 56. Now the next step we are taking in solving this question is to factorize, and we can factorize when our equation is equals to 56. So what do? We try equating it to 0. Now how do we equate it to 0? We're going to try getting rid of 56 by adding negative 56 to both sides of the equation, since 56 here is positive. So this will give us p squared minus p minus 56 is equals to 0. And finally, when we factorize, we have p plus 7 brackets close multiplied by p minus 8 brackets close is equals to 0. So our first value of p is equals to minus 7 and our second value of p is equals to 8. Now when p is equals to minus 7, we remember we said our p is equals to x raised to the power of 3 all over 10. So we have x raised to the power of 3 all over 10 is equals to minus 7. Now to get our x, we are going to raise both sides by the inverse of 3 all over 10. And the inverse of 3 all over 10 is 10 all over 3. So we have our x raised to the power of 3 all over 10 or raised to the power of 10 all over 3 is equals to minus 7 raised to the power of 10 over 3. Now our 3 over 10 is going to be cancelled by 10 over 3, because when you multiply you get 30 all over 30, and 30 all over 30 will give us 1. So here we have our x is equals to minus 7 raised to the power of 10 divided by 3. Or you can say our x is equals to the cube root of minus 7 raised to the power of 10. Now when p is equals to 8, we can say our x raised to the power of 3 over 10 is equals to 8. Then again we can say our 8 is equals to 2 raised to the power of 3. So we have x raised to the power of 3 over 10 is equals to 2 raised to the power of 3. Now to get rid of 3 over 10, which is the exponent of x, we can raise both sides by the power of the inverse of 3 over 10, which is 10 over 3. So we have x raised to the power of 3 over 10 or raised to the power of 10 over 3 is equals to 2 raised to the power of 3 or raised to the power of 10 over 3. Now as we did on the other side, our 3 over 10 multiplied by 10 over 3 is going to give us 30 over 30, which after dividing will be left with 1. So we have h raised to the power of 1 is equals to, now on the other side of 2 raised to the power of 3, 3 multiplied by 10 all over 3, we have 30 all over 3. And 30 all over 3, that is dividing 30 by 3, will give us 10. So we have our x is equals to 2 raised to the power of 10. So these are the values of x. I hope you enjoyed this video. Please don't forget to like and also subscribe. Thanks for watching. Bye.